Welcome to my channel. Today we are going to talk about how table partitioning and clustering can help improve your query performance and be more cost-effective in BigQuery. We'll first describe what the problem is and then show the improvements we can get when we partitioning and clustering BigQuery tables, and lastly, we will demonstrate how partition and clustering table works and their limitations. Let's dive in. First, let's create a dataset called demo. Pick US as data location. Set table expiration to any days you like. Let's pick 7 days. It means after 7 days, your table will be deleted automatically. Now click Create Dataset button. Okay, dataset created. Now let's find some public data to work with. Just type public data. You may need to click Broaden Search to all projects. Click the star, so that it will show up in Explorer panel later. You can see there are lots of public dataset. Let's pick international top term, which is the top Google search terms in each country. Let's see its schema. It has country name, region name, rank, term, etc. Let's preview its data. Let's select a subset from international top term dataset and create our own test tables. First, create a table named top term original which has no partitions or clusterings. Let's see the oldest data in the table. It has 5 years data, so roughly less than 2,000 days, so we can create a daily partitioned table with 2,000 partitions. Then let's create a partitioned table called Top Terms Partitioned. It partitioned on a date column called Week. Now, let's create a clustering table called Top Terms Clustered. It has 2 clustering columns, country name and region name. Lastly, let's create a table that is partitioning on the week column and clustering on country name and region name columns. Now let's see how the same query is processed for each table. The estimated bytes to process is 353 megabytes for non-partitioned and non-clustered table. The estimation is based on how many partitions to scan and how many columns you select because BigQuery is columnar based. Let's see how much bytes to process the same query for the partition table. Wow, much less, just 1.35 megabyte. This is the actual bytes processed, same as estimated bytes. The smallest billing unit is 10 megabytes. Let's see how much bytes for the clustered table. The estimation is same as original table, but let's see the actual bytes processed after running the query. It's about 24 megabytes, which is over 90% less than the original table. Lastly, let's see the table has both partition and clustering. It's a little less than the estimated 1.35 megabyte because the clustering is also help reducing data need to be scanned. Let's visually see an example of how partitioned table organize data. You can see the rows with same date will be in the same partition. When we filter on the value of the week column, BigQuery can scan the partitions that match the filter and skip the other partitions. This process is called partition pruning. There are three types of partition: time unit columns such as timestamp, datetime and date, integer column, or ingestion time, which is the time when BigQuery ingests the data. Let's see some example SQL how to create each type of partition tables. There are two special partitions created. The null partition will contain rows whose partition column is with null values, and unpartitioned contains rows with data earlier than January 1, 1960 or later than December 31, 2159. Partition on date column and data for the same month will be saved in same partition. Partition on the pseudo column named partition time. Partition on department ID, starts at 1, ends at 100 and interval is 1. Here are a few things to note about partition. First, as of December 2022, you can have max 4,000 partitions per table, so you need to be careful when you partition hourly or daily. Second, you can only choose one column as the partition column. Lastly, only the above talked data types can be used for partition. For example, you can't partition on a string column, but you can clustering on string column to help query less data. Now, let's see how clustering organize data. You can see when we clustering on country name and region name, rows with same country name will be close together and then with same region name will be close together as well. Here are some things to note for clustering. First, you can cluster on at most for columns. Secondly, the order of the clustering columns matters. For example, if we clustering on country name and region name, then only first two examples will take advantage of clustering. Lastly, let's see how both partition and clustering organize data. Data will first put into its own partition and then order by clustering columns. That's all for today. Hope it helps. Thanks for watching. Don't forget to subscribe if you would like to see more of these. Happy coding! See you next time.